Hello everyone. On behalf of Indian National Trust for Art and Cultural Heritage INTACH and the INTACH Conservation Institutes, I extend a very warm welcome to our distinguished speaker, Dr. Nikhil Joshi, and everyone who has joined us for today's talk in the Conservation Insights 2020 lecture series. I'm Dr. Padma Rohila, Director ICI Delhi. Now to introduce our speaker, Nikhil Joshi is a senior lecturer in the Department of Architecture at the National University of Singapore. He is educated at the University of Pune, University of York in UK, and the National University of Singapore. His research interests include cultural heritage management, traditional building materials and techniques, and community participatory approaches. Before joining NUS, Nikhil worked and taught in India, UK, and Malaysia for over a decade. He is a fellow of the Royal Geographical Society UK and the recipient of the Society for the Protection of Ancient Buildings, Lethaby Scholarship from UK. He has been an active speaker in various conferences throughout the world and has several publications to his name. His main recent publications include Mahabodhi Temple at Bodh Gaya, Constructing Sacred Places, Deconstructing the Great Case of 1895, published in 2019, Managing Change, Urban Heritage and Community Development in Historic Asian Cities, edited by him, published in 2018, Community Voices, Preserving the Local Heritage, published in 2016, People and Places, Exploring the Living Heritage of Songkhla Old Town, edited by him and published in 2016. The title for today's talk, as you all know, is Like for Like Repairs, why lime matters in built heritage conservation. The origin of the word lime is from the Old English lim, meaning sticky substance. Lime was used as a binder for most historic buildings and is a vapor permeable material that lets buildings breathe. It reduces the risk of trapped moisture and consequent damage to the building fabric. Singapore's rich and varied heritage consists of many national monuments, conserved buildings, and marked historic sites. For them to remain meaningful and useful to the future generations, the present generation must take care in a way that they tell stories of the past through various layers of the building fabric. Using an ongoing project in Singapore, this talk will cover the importance and implication on the use of lime in historic buildings and why this cost-effective and traditional method is far more effective than Portland cement and synthetic paint. Before I invite Nikhil to start with his presentation, may I please request all of you to put your microphones on mute. We'll be taking the questions right at the end of the presentation. So please do type in those questions in the chat box. I'll be keeping an eye and then we'll be taking them up at the end of the presentation. I now request Nikhil to start with this presentation. Thank you so much for agreeing for this talk. I know you're very busy and but still you took the time out. So welcome, and please, if you could start the presentation now.
Right. Thank you, Padma, for the introduction, and thank you all for joining today. I know you were just saying it's Friday evening, and so people want to just relax. So I'll try to keep this entire talk short and sweet. I'm not going to into too much of details, the chemistry of lime, which I love to, but then this is more or less overview, and like my title suggests, is I will be talking about why like for like mortar repairs are important, and why lime. So that's the crux of, and I will be giving examples from India, and even from York, and mostly my examples will be from Singapore and Malacca, which is in Malaysia. It's a World Heritage Site where I generally work. So I'll start. As introduced earlier, lime is from lim, which means a sticky substance, and lim is also a surname in Chinese and in Singapore. So I always make fun of it when I'm giving a talk here. But anyway, so it comes from lim, which means a sticky substance. And limestone, lime, as we use in the building material, is mostly manufactured. We don't get it from nature itself. So what we get from nature is basically limestone, which is a sedimentary rock made from the dead bodies of sea creatures that produce calcium carbonate. So mostly Lime is the limestone is calcium carbonate, which is CaCO3, which contains which can be found in coral, shellfish, some planktons as well. And most limestone was laid down in the Cretaceous period of around 150 million years ago. Lime, various uses of lime in building is through mortars, renders, plasters, slurry, and lime washes. And lime, as in the introduction, Padma mentioned, is was being used for most of the good number of years until the Portland cement, which we know as a normal gray cement, which we use nowadays for modern buildings. It's a very kind of a recent invention, and unfortunately or fortunately, it's the lobby of Portland cement manufacturers is quite strong, and that is the reason, and this is my understanding, that lime is actually the technique and the building material is kind of dying day by day, and because the business of Portland cement and the industry of Portland cement is very strong, so they want to push for the use of cement. And just to remember that it's a very recent invention, Portland cement, the gray cement which we use for mass building, and it's early 20th century. Before that, whether it is the Pantheon in Rome, which you see on the top, um, um, which is this one, a huge dome, as some of you may know, may have visited it. This site, this picture is from Penang, Georgetown in Malaysia. Again, a World Heritage Site, and this is from Jaipur. The, the Havelis, you can see the use of lime, beautiful lime wash and lime plaster. And this is the top is this one is St. Paul's Cathedral, St. Andrew's Cathedral, sorry, in Singapore, and again built in lime plaster, brick and lime plaster. So all these which are pretty old, and some of them are very old, like Pantheon, are built with lime, so brick, lime mortars, and lime renders. So before the advent of Portland cement, our buildings, and they are still lasting. So it's not like lime is weak or bad, or cannot build huge buildings. All these are quite remarkable and huge buildings. They were built, especially the Pantheon and the St. Andrew's Cathedral. They were built with lime. Okay, uh, as I'm from India as well, and giving a talk for INTACH, I thought it is important for me to share something that lime was how lime was important. Even, I mean, this slide which you're seeing is a code of practice for application of lime plaster finish, ISI standards, and this was published in '84. This particular document, but this is the first revision. The actual document was published in 1965. So just after, means less than 20 years after independence, they were still using lime for buildings, and there was a Indian standard, ISI standards, for how. It's a remarkable document. It's available online. If you have time, please go and have a look. And it tells everything. It talks about, as you can see, it talks about the the terminology. It talks about the scope. It talks about the recommendations for lime, and so it's a remarkable document. So it shows that until quite recent, which is 1984, we were still the lime was an important building material, or and it was even the ISI standards we have for the lime, how to use lime plaster finishes. Okay, I will just quickly show for people who are new to lime, and so how when I said that lime is lime, what we get from the nature is limestone, not the lime which the lime putty or mortar which we use in the building material. So this is a very brief video which shows how lime is actually quarried. The limestone is quarried and then burnt in a kiln, and then made usable for the plaster which we see. So the short video just to show the quarrying of limestone. So yeah, just this is the quarrying of limestone from a lime hill, and then it is the big chunks of the limestones are then fed to a feeder, and then it will be sent to, oh dear, kind of, and then it will be sent to the kiln. And so this is the kiln. The big pieces are now burnt, and I will come to details of the actual process. So now they are crushed to smaller pieces. The bigger pieces are crushed to smaller pieces, and the smaller pieces are now, and then later. So this is crushing of bigger pieces to smaller pieces. So it's easier for them to burn it. It takes less energy. And then this is the big industrial kiln when and they fire it to a very high temperature, and I'll come to details of that. So right, so this is basically the process of quarrying limestone and then burning it. I'll come to the details that why it is done, why it is burnt, and everything, because the form you get limestone is not usable for building purposes, for your lime plaster or mortar and everything. So I'll get into the details of it later. But this is another way of finding. So in most of Hong Kong islands and in Singapore, since we don't have that sort of lime quarries here, limestone quarries here, so what is can be done is you can collect the seashells, the corals and the seashells, and then you burn them, and it's the same calcium carbonate, CaCO3. So it's the same as the limestone you get from the quarry. And as you can see in this slide, so these are the shells, and these are the shells used in the mortars. So you can see a cement, like a lime mortar has used a lot of shells, because shells are the same composition, chemical composition as a limestone. So once you don't have it in Singapore, because we have a lot of sea, same in Hong Kong, and this picture is from Hong Kong actually. So the islands which don't have lime hills or limestone hills, this is how the lime was produced for building purposes. Okay, coming, as I promised, coming to the slight chemistry of lime cycle, what we call it. So this is the lime cycle. As you can see, I've just shown you the video of how the lime is quarried. Lime. So this is number one. So lime is quarried from limestone or chalk. This is called calcium carbonate, which is CaCO3. Then the limestone or chalk is burned with the fuel. And earlier it was coal and wood and other things, and now it is gas fired and many other, because it's industrial scale. But earlier it was more like a smaller scale. You want to use it locally. You make a local kiln and you burn. So it was burned, and then when you burn CaCO3, what happens is, it's very interesting. You have to remember this, because this shows that when I say that lime is the most greenest building material, is why lime is like that. So limestone is burned so that the carbon dioxide is lost, and this result in what we call as quicklime or calcium oxide. So CaCO3, when you burn, is basically the CO2 is released, and that's why it's called quicklime. It's quite active, and what you do is you add water to it, and the process is called slaking. You can and then you get the mortar, and then you apply the mortar or render, and then what happens is it lose water, of course, by it lose water, and it absorb carbon dioxide, and it goes back to when I say it loses water, means it's evaporation. I mean, it's slowly and slowly the more water and you have mixed here water and sand is lost. And then, but what amazing thing happens in number 6 is until the building is standing, until the building is standing, it is actually absorbing carbon dioxide. And it absorbs carbon dioxide. So I don't know any other material, building material, which actually absorbs carbon dioxide from atmosphere. And by doing that, it is again going back to its original form of becoming calcium carbonate. So lime, unlike cement, is a soft material. It doesn't harden quickly, and the process is slow because it is slowly losing the H2O, and it is slowly absorbing CO2. So even after a few years or even few decades, you can actually break lime plaster with your bare hands, but you cannot do it after 2 days for a cement plaster, a Portland cement if you have used. You cannot break it because lime is such a soft and a forgiving material, and it doesn't harden very quickly. It hardens slowly because it is absorbing CO2 from atmosphere. So if you have a building, if you have a group of buildings, if you have the entire country made up of lime plaster, then actually the buildings are absorbing, or the plaster is absorbing CO2, and that makes the lime as the most greenest material for building material. So it's amazing that how it absorbs CO2 from atmosphere instead of releasing the CO2, which we, the greenhouse effects and the carbon footprint and all that. It does all the opposite of it. And then so number 6 is very important, which makes lime a very green material for. So these are some of the lime kilns in the historical lime kilns, and you can see that how they were in the video. You remember there was a industrial lime kiln which was burning through either coal fired or electric fired, but here you can see lime, the it's there's a layer of coal, which is the material for burning, and then you have lime, and then the burnt material can be collected from here. It's pretty easy, no rocket science. You just need to find a higher, so like a small hill, and it does the job. In the past, you because it was not a very refined process. Sometimes with the burnt, the quick lime. So what you are collecting here is basically quick lime, and you're actually adding limestone, so it's releasing CO2. It's becoming quick lime, and with this quick lime, because it was not a very refined process, you sometimes get the coal part of it, and when you see the old plaster, you see black dots there, and that's a coal which was used to burn limestone or calcium carbonate to make workable quick lime. Very quickly, again, it's quite important to understand that how actually lime differs from the Portland cement. As you can see in this slide, the pure lime is the most center circle, basically. So what happens is you have the pure limestone, which has the highest percentage of calcium, and then you slake it, and then it becomes lime putty. And I will come back to it, what is exactly lime putty. But that's so when I say slaking, you are mixing H2O with that to quick lime, and then it becomes like a yogurt form, and that's a usable form which we use for actually the plaster finishes. And then it carbonates again. It absorbs CO2, and it becomes pure lime. So the central this part is the part which we are mostly interested, because we are dealing with the good quality of lime. The impure limestones, which has got some impurities like magnesium and other impurities, then you fire them, and then when you fire them to a different temperature, what you get is you get a hydraulic quicklime, not a pure quicklime, because it has got some impurities. And then you hydrate, means you add lime to the water to it, and you get natural hydraulic lime. So they are different. So when I say pure lime or lime putty or quick lime, they are slightly different because they have different impurities in it. So NHL is a different class than the pure limes. The last one, which is a limestone, which has got most impurities, which is this one, has got a clay mixture and everything else, and you have to fire them to a higher temperature. You make clinker, you grind it, and that's how you get the Portland cement. And it has got, so Portland cement, if you see among these three, has got the highest impurities. The temperature of firing is different, and that's how the chemical properties is also different. So reactivity of lime, if you see here, is basically based on lightly burnt, hard burnt, overburnt, and dead burnt. So if it is lightly burnt, which is a pure lime, it is of high quality. And then the hard burnt, overburnt, and dead burns are basically almost inert, so they don't react with water. So you don't get the workable lime putty and things. NHL, which is slightly impure, are classified. They are also used in building in buildings, and they have different uses. But I'm just to classify them according to the British standards. NHL can be also used, and NHL, they are different strength. They are classified as NHL 2, 3.5, and 5. We generally use sometimes NHL 2 for buildings, but 3.5 and 5 are very, very strong. So I don't generally recommend to use it for historic buildings. They have different uses. They are very strong, and 5 is actually even stronger than the cement. So if you're talking about softer building materials and like for like repairs, you probably have to stick with pure lime putty or quick lime, and in some cases NHL2 as well. Okay, coming back to what is a non-hydraulic quicklime is the quicklime is a purest form, like I said earlier, and this contains almost 95% of calcium carbonate, CaCO3, and it is burnt, again explained earlier, in the lime cycle. CO2 is driven off, and what we is left with calcium oxide, so CaO. And this quicklime is, when we add water to it, it becomes lime putty, and I'll come back to it. But it can be also used as dry powder formed as well. So you add just enough water to it, and it's easier to transport, and if you are transporting it to long distances. Like in Singapore, unfortunately, we don't have uh, uh, lime any more lime. We don't have the either the quarries, or nobody collects the shells and burn them. So we have to get our lime from far away, from Malaysia. So this is a better way of getting it. But in most of the cases, if the project is smaller, and you want to do a finer finish, we generally get it as in a form of, I actually produce my own lime putty, and I'll come back to it. So this is how we get quicklime, and it's also called builders. You can find it in the builders merchant shops. Okay, this is me preparing in my research center in Malacca lime putty. So I'm mixing, if you remember, I'm mixing CaO, which is calcium oxide, with water, and it is quite a combustible process. I mean, it's you have to be very careful. You can get skin burns and everything. So as you can see, the lot of heat is coming out. You can see the steam. It's almost boiling basically, and you can see the boiling process. And then you mix quicklime with water, and you get this, like I said earlier, I call it gooey cheese, or in a form of, or like a yogurt, slightly thick yogurt. And then we mix it, and then we keep it in a mature, we keep it for few months. In UK we call it grandfather produces and grandson uses. That's the best quality of mature lime. So it's always advisable to keep it, if you are doing a finer finish, like a plastering job, to always leave it for a few months, probably 3 to 6 months, and we call it as a mature. And then you can pack it in a then you cannot pack it in a bag. You have to pack it in a plastic container, and then you can transport it. So this is how we are actually producing our own lime, so that we are pretty sure that we are using the good quality of quick lime, which is 95% calcium, and firing it to a proper temperature, and then maturing it enough to get a mature lime putty, which we use it for plastering. Hydrated lime is also is bag lime, but the problem with this is, because the bags are not sealed, so sometimes the carbonation occurs inside the bags. So by the time you mix it to make it a plaster, or a mortar, it's actually already carbonized. So it's because it's paper bags, or sometimes the gunny sacks, and they have the holes and everything. So it actually absorbs water from the moisture from the atmosphere, and also, so it's not a good quality. So it's already carbonated in the bag. So if hydrated lime is the only option to be used, it has to be used as fresh as possible, soaked in clean water for a couple of days or longer to form a putty. So same way, but this is kind of a powdered form. It's not in a stone form. And even with this preparation, it is not good as proper lime putty, because it's you're not 100% sure how it is stored, and the quality and all that kind of stuff. But again, these are some sort of compromises we have to do when we don't have the proper material. But I have seen it in many countries, including Thailand and even India, of course. We still have companies producing traditional quick lime, and then you can have your own small setup like me in the bathtub doing the lime putty, and you know that your lime putty is good quality because it's matured. Maturity is very, very important. Lime putty is exactly like a good wine. So the older it is, the better it is. NHL, if you remember NHL, I mentioned earlier when I was talking about the impurities. NHLs can be used for certain building or building purposes or sites, but then they are not pure. They have impurities inside. NHL2, yes, feebly hydraulic, soft permeable masonry, minimal exposure, you can still use it. But then NHL 3.5 and 5, as you can see, they are moderately hydraulic and eminently hydraulic, which is a very fast setting. And their typical use, I'm just reading for NHL 5, is engineering brick, basalt, paving, roofing, chimneys. So very, very the building materials which are quite strong, which are not as soft as bricks, which are clay breathable materials. Okay, so I dare not to touch with 3.5 and 5. Sometimes used to, but most of the time I use lime putty. Okay, talking about impurities, it's just that why impurities are so important. You have to remember that what you get is basically CaCO3, and when this limestone, when we burn it, the carbon dioxide is driven off, right? When we are burning it to a temperature, and that temperature is basically 898 is the optimum. 900 is the optimum temperature to round off, basically. But if it has the impurities, which are let's say magnesium oxide, which is a very common one. The magnesium oxide actually, the dissociation temperature of magnesium oxide is 760. So let's say if you want to have a good quality calcium oxide, the quick lime, and you want to burn it till 900 degrees centigrade. But by that time, MgO, which is the magnesium inside, the impurity inside that is already hardened, because their dissociation temperature is only 760. So that makes MgO hard burn. You see, you want to burn your limestone to 898, but the impurities are already hard burned at 760, which is almost like 140 degrees centigrade less. So when you slake it later, when you mix it with water, and you want to have that charch or buttermilk or gooey cheese or yogurt, the strength, the MgO will not slake, because it is less active. It is already very hard burnt. So MgO is not desirable. So what I always say to people is, whenever you are buying your lime putty or limestone, please ask the supplier to provide you with a specification, that the technical data, that how much is the chemical, what are the chemical properties of it. And sometimes they try to fool. They're saying, okay, calcium oxide and magnesium oxide in this case is I was told that 97.6, which people will say, wow. But then you don't know how much is the calcium oxide and how much is the MgO. So you never know whether it is 50-50 or 50-40. And then on top of that, they are also saying that you have an MgO which is 3.1, 3.01%. So all this makes MgO more than the calcium oxide, which means the limestone, the usable lime you are getting, calcium oxide or lime putty, is not very rich in calcium. So that means your plaster and everything will harden very very fast. It will not be a good job. So be yeah. So that's how sometimes when I deal with the suppliers and people come and talk to me saying, oh, we have this very good quality of lime putty. Do you want to use it for your repair works and things like that? So the simple thing is, can you provide me with the specification, the chemical, the properties of it? And if I see that the calcium oxide is less than 95%, I say thank you very much. I know I can prepare my own lime putty, which will be much better quality, and I know what limestone I'm using and how I'm preparing it, and I mature it to certain number of months, 6 months, 1 year probably, and then I know I'm using the right material for the right building. Very quickly, what are the benefits of lime over cement? So like I said, I was saying that like for like repairs, right? Because if you're dealing with a building which is 100 years old, 150 years old, it's pretty. I'm pretty sure that it is built with lime. So we have to repair it with lime. Otherwise, the compatibility of materials of the soft bricks, which are clay, and the hard cement is not good. And I'll explain later why the compatibility is important and why like for like repairs. But before that, a lot of people come to me and say, what are the benefits of lime? Because they don't understand, because they only see lime as weak and it takes a lot of time to set and everything else. So I just tell them this few points that what are the advantages of lime over cement, and I'll just quickly read some of them. Is carbon neutral, like I explained earlier. So it reabsorbs CO2, which is the fantastic thing. Cement does not. Lime is recyclable and biodegradable. So and also the buildings which are built with lime, you can actually demolish them properly, and then you can reuse. In most cases, if they are demolished properly, then you can reuse the bricks, because it's unlike the hard cement. The lime easily gives up, and you can actually reuse most of the original bricks for rebuilding or for something else. Lime is burnt at around 900 898 degrees centigrade compared to 1300 for cement. So that means you are using more energy for producing cement. Again, more greenhouse. CO2 emissions in manufacturing is 20% less than cement. Lime is less dense than cement, so that means less weight, and then so it's easier, same quantity, easier to transport. So it saves on fuel if you are transporting it for the longer distances. Lime, this I've already said, allows bricks to be recycled. Cement contains heavy materials which puts on air on burning. Lime doesn't. Lime is an important part of our natural house, involving timber, straw, lime, and earth buildings, and it's very natural, healthy, and biodegradable, because unlike cement, which has heavy metals inside. Just for architects or people who understand drawings, I think this is self-explanatory. Basically, I say lime is breathable, so any water which is entering, and we get this problem everywhere, especially in Penang, in Singapore, because we are surrounded by water, so water table is quite high. So any water, any excess water which is if you are using lime concrete or limecrete, we call it, it can be easily dispersed. So any water which is from the base of the building or the floor can easily come out from the joints, because you are using limecrete, and it can evaporate. So soft made terracotta tiles on top. But in case of cement, which is hard, if you have a cement concrete base and have some sort of the hard tiles nowadays quite cheap to buy, and if you do that, water has no way to come out. So what will water do is water will try to find soft spots in the wall. And of course, the if it is a brick wall or a stone wall, it is quite soft. I mean, of course, brick is softer. So clay will give way, and then the water will go up, and then you find the rising dampness problems. But if you have lime plaster on the wall, again the surface area will help water to actually evaporate from the clay wall, the clay bricks. It will evaporate from the plaster. So you don't get those damp patches. You will get damp patches, but you don't get a lot of issues like the molding and everything. But in this case, water has no way, because you have done again either modern paint or tiles, which is non-breathable, cement plaster. So water will go up and up and up and keep on damaging the bricks, and try to find out some way, because water has to come out from somewhere, otherwise it will explode, like a volcano. And where it will explode, if it finds in this part of the world, we usually see the timber beams. And that's again a soft spot where the water will come out, and you see all those rotting of timber boards and timber beams. In this case, water is coming out from many places, so our timber beams are much safer, and the timber boards are much safer. You don't get all this rotting of the corners, and most of the time you have to repair it. And if you don't look at it, it will actually create more problem to the building. So lime is breathable, in short. And any water which is entering through the base, the earth, the floor, or anywhere else, will have a lot of opportunity to evaporate. You will find damp patches. So there's nothing to worry, which means your building is breathing, and the water is actually, if you have cross ventilation, and if you open the doors and the windows, you will find on a fine day in Delhi, with the temperature going 50 degrees or 47, it will evaporate very quickly. So this is what happens. Just to show the reason. If you have the stone or a brick, and you point it with lime, what does this magical lime does is if you have a rain, then the of course the clay bricks will absorb some of the water, and then the water will come out from these joints, which is the lime joints. And even the rising damp will do the same. So what happens is so the upper picture which you see was actually pointed with lime. The pointing was done with lime mortar. And then you see that lime mortar is actually given away. But if you have done it with a stronger cement, which you can see in the below picture, the cement is strong, so it doesn't allow water to go to evaporate. And what happens is the softer bricks have to allow and then this sort of thing. It is very common if you use the wrong pointing material, which is cement versus the lime. You see this sort of thing, and it's very easy to repair the upper picture, because what you can do is you can go back and you can repoint it with lime, and bricks are in very good condition. You just go and in 5 years, 10 years, you repoint it, so no issues. But here you have to actually, if the condition is really bad, you have to demolish the entire wall and rebuild it, if the pointing is wrong, because the rising damp has no way, and the rain has no way to because it's impermeable, and the lime mortar is breathable, so it allows, otherwise it will erode. The bricks, the softer material will erode. And that is the reason why I say like for like repair and compatible materials are very important while repairing historic buildings. This is another example, and this is from the previous example was from Malacca. I mentioned it's a World Heritage Site, and a lot of people have no awareness of this like for like repairs, or how lime is a wonderful material to repair. And they choose wrong materials, and in a way, in a long term, they are actually damaging the building. This is in Vegan, which is in Philippines, another World Heritage Site. And you can see the other, this one is lime, as you can see some of the white spots as well. And you can see lime has eroded, and the bricks are still in a very good condition. So what people have to do is, if they do regular maintenance, this thing will not happen. And then you do and the proper regular maintenance, the bricks are good, and of course the weathering happens, but then you repoint it, and they're good. But then the same place, some people don't understand the importance, and they have replastered it with cement, because it's cheaper. But as you can see, cement is a hard material. It's right there. And I always give this example that cement is like father, and lime is like mother. Mother will do anything for their children. Means so mother will give away, all the, so mother will give the good things for their children. but but cement being a big boss, it will still hang. It will say no, it's a hard material. It's a hard material. So what is going to erode is the soft bricks, and as you can see, they're eroding and they are in bad condition. Same place, vegan, and it happens all over the world when there is a lack of awareness that why we should use lime for a building which was actually built with lime. Another important thing with lime is soft and flexible. So this is Oxford in UK, and as you can see, this timber beam, it's almost, it's not flat. Building must be 100 plus years old. It's sagging, and being a soft and flexible material, lime actually sags with it. It's like so you don't get cracks. But cement being a strong material, you straight away find cracks because it's not sagging with the building, and then it's very easy for rain to go into the through the cracks and rot the timber structures. So lime is soft and flexible, and it moves with the building. And this is just one example. I've seen building like Tower of Pisa, Leaning Tower of Pisa, in Pune as well, in near Pune, in Saswad. And yeah, so the entire building was tilting, and there was absolutely no cracks because it was built with lime, and that was a brick and timber structure. Lime being versatile, and I just want to stress that lime has been used all over the world. And the first two pictures, the Jodhpur, Jaipur lime washed, and this is Singapore. This is NUS's, my department's research center, and this is the house. We call it Baba House. It belongs to our department, and this is my laboratory where I work with different techniques and materials, which is fantastic to have such a living laboratory for to work with all these materials. So I do all my experiments here, and I'm not ashamed to say that sometimes I fail. So I learn from it, and I change my methods, my techniques, my composition, and I experiment again. And if I'm happy, then I continue with the project. Means I do it on a bigger scale. So not just lime, we also, not just plastering, we also use it for other things like recording. And this is just I mean, I've been working on this since 2016, so it's almost 4 years now. Very well received. Now we train contractors here. We even train the government agencies people, the policymakers, about materials, conservation architects, professionals as well, about the use of lime and other traditional building materials, and why we have to use it. So instead of giving them a lecture like a PowerPoint slide saying, we actually do hands-on. So they do it. So in 2016 when I started with small patches, and like I said, I did different compositions. I experiment with it. I monitored it for a few months, probably more than a year actually. And then when I was happy with the composition and with the materials and everything, then we started last year. We did the entire ground floor of this beautiful house. This wall you are seeing is done by the participants of my lime workshop. Trust me, I'm not saying because me and my participants have done it, but it's a wonderful, and we have lime washed it. So it's a wonderful example. We all feel very proud of it, and now we use this I mean, it has been in the media, national television, everywhere else, for awareness about traditional, not just lime, but about other building skills as well. This is a project in Ho Chi Minh, another one which I was briefly involved. Lime wash I mean, lime is such a wonderful material. This is a villa in the historic district 1, and after so many years, this is 100+ year old building. And when we started cleaning it, we found out that even after a few hundred years, under the different layers of lime wash, you can still see the original paintings. And of course they are done it. So the future project is to restore them, of course, repaint them and retouch them a bit. But then this is the beauty of lime, because it's such a soft material. You can actually clean it even after a few hundred years or few decades, and you can still find the original material. which is still there. But you cannot. I mean, you can do it with the modern materials as well, but it's very expensive, time consuming, and in most cases you will not find the real thing quite intact like this. And this building was built with lime, and then lime wash, and all these the paintings and everything was done with natural pigments. This is the birthplace of Shakespeare. I'm forgetting the name. But then again, you can see the timber frame buildings uh, built with lime, and also the timber was also lime washed. When I say lime wash, it's like I will explain what is lime wash later very briefly. But it's like a paint. It's like a very thin paint, and you can lime wash it. Even the timber, and it is said, I have not done an experiment, but I have read many places. And when I speak to experts, timber experts, they say that it works as a anti termite. So actually termites hate lime. So if you lime wash it, it looks quite nice as well, as you can see in the picture below. All these timber structural elements are actually lime washed, and it also acts as a anti termite, which is fantastic. So it's two in one, buy one get one free basically. This is the actual work we were doing in Baba House, the blue Pranakan house, my lab, scientific lab basically. So all the participants are mixing lime water. So it's very hands-on. It's not like they are standing and taking notes or looking at my slides and everything. They do actually hard work, and I do and stand there and tell them how to do it. So the contractors, this is a conservation contractors people here. So I've been trying for several years to it's kind of a lime revival in this part of the world, because as some of you may know, Singapore is kind of a very developing or developed nation in Southeast Asia, one of the developed nations. So everything is about high rises, iconic buildings, tall buildings. So it was initially quite hard, but then now, I mean, after 3-4 years, I'm quite pleased that more and more people understand that why do we have to use lime for a building which was originally built with lime, because of the compatibility, because how lime differs from cement, and in the long run, how lime is going to help the building, and cement, how it is going to cause issues in the long run. This is the project in Malacca, and I'm again very happy to share with you that in the morning, in the afternoon actually, and this is another historic house, quite old, 120 plus. It's a Baba Nonya museum. It's next to, it's in the right core zone of the World Heritage Site in Malacca, and it's next to our another research center in Malacca. We have another research center in Malacca where I use two historic buildings, which I train my students. I do my experiments there as well. And so I was asked to help this old house, which is our neighbor actually. And for the last 2 years, I've been again training, mixing, and doing my experiments on a smaller scale to understand how the lime plaster actually behaves in different environment, because this house is a working museum. So they have some areas which are fully air conditioned, some areas which are open to sky, and some areas which are non-air conditioned. So I was experimenting that how different mixes are working in different conditions. And also like I said, I actually worked with the real stuff rather than working under the microscope and saying that, okay, this works in the laboratory, but that may or may not work in the live building. So this is in Malacca, and again testing small portions on a real building. And in the morning today, I was told, because we were very happy with the plaster and how it was behaving for the last 8 to 10 months, that we decided to repair a larger section of the building, and slowly we will repair the entire building, so that at least it gets because it has got a lot of issues. It's not that I just wanted to use lime here. So it was getting issues of dampness, and how in the past they had no records at how it was repaired in the past. So we decided that we will do a trial patch of, let's say, 2 meters by 2 meters in different locations, and record it, monitor it for a few months, and see how it works. And if we are happy, we'll do the. So in the afternoon, I was told that the contractors are on site, and unfortunately I cannot travel because of the COVID thing. But the contractor is on site, and they have started taking the existing plaster, hacking it nicely with by hand, not with a machine, because we don't want to damage the old bricks as well. So this is like I said, the real stuff. It needs some sort of patience, and I think all old buildings need patience. So there's no quick fix, and there is no quick fix, no fixed recipe as well for working with old buildings, because all of them are unique, and so they might be showing the same issues of like dampness or some sort of ingress of water and all that kind of stuff, but they might be that the actual issue is quite different. So you have to be very, very careful. And I'm just showing one example of lime, because today's topic is of lime, but how we are using lime in different conditions. Few examples. I used to travel earlier extensively for work and for other things. And this is in Suzhou, another World Heritage Site in China, known beautiful Chinese gardens and beautiful old buildings. And this is, as you can see, as I was saying, it's not just in Oxford that the buildings were lime washed. Here they have actually plastered it with lime. So the big, huge timber pieces, which are exposed to the elements, and this is the external like a veranda. So they when they were the timber was showing some sort of issues, they actually plastered it with and then they lime wash it. So as you can see, it's not just in West, but very much in the East also. There was this tradition of plastering or lime washing a timber with because they are both natural materials and they talk to each other. They are very compatible and find no issues. What you see here is the condition is because this building has been not in use for almost 7 years. So otherwise, I'm sure if somebody is living inside, they will take care of it, and this will prolong the life. The lime will prolong the life of timber and the house. Uh, I think most of you will know about the Great Wall of China, very famous. Again, that was built with lime few 100,000 years ago, Ming Dynasty, most of it. And again, when they were repairing, they started repairing it. They started with, unfortunately, they started with cement because they wanted to do a quick job. What we see or what we see in the pictures of Great Wall is only the touristic Great Wall. Otherwise, Great Wall is it goes for thousands of miles, and some of the conditions are very harsh. So they wanted to do a quick job, and they were very badly criticized. Then they realized that, oh, we have to use lime, which was the original material used for building. So this is the recent, I think it was 2018, when they started repairing it with like for like repairs. So they are using brick and stones, and using lime mortar for fixing it. And this lime mortar is different from my lime putty, because lime putty, like I said, is like fine wine. So you will not serve it if it is a banquet, then yes, of course, you are going to serve wine, right? But if it is a normal meal, then you will probably have a beer. So this is a hot mixed lime, and so the process is same, but instead of using lime putty, which is for finer work, they are using hot mixed lime here, which is using the same calcium oxide, but instead of maturing it and water and everything, they're actually using the calcium oxide and mixing it right there with water and sand, and using it while it is still hot. Because the lime putty is quite expensive because it's time consuming. It's mostly used for finer works, not for building like this sort of huge structures. It's actually can be very expensive. Another example, I've been talking about the East. This sort of building, what you see, this is York, where I studied. This is York Minster, and huge building, and they keep on repairing it. So they use lime here, and I have a good friend. As you can see, they keep shifting the scaffold. So one section is finished, they move the scaffold. So every time of the year they will have scaffold somewhere or the other, but the entire building is built and repaired with lime. And this is how they are doing. They're also experimenting it there, because sometimes you don't get the actual material. The quarry is closed, or the sand is different. So they are, I was quite pleased when I went there, and I was talking to my friend Lee, who is a stonemason, and involved with this work very, very closely. And I saw that the bathtub there, and I was very happy that, okay, fine, I'm not doing anything wrong, because I'm using a bathtub in Malacca as well, if you remember the previous slide. And that's exactly what they are doing. They are trying to, they are using the mature lime. They are trying to match like for like repair. So they are even trying to match the color and the aggregates of the sand. And of course, they are using Carlbach's Grand 15, which is a quick lime, as you can see here. It's a locally produced, but I think it's a French company now. It's bought over but it's from Buxton Lime. Earlier it was so the query is in Buxton, and it's a quick lime. So same process, and it's not rocket science basically. It's just like I said, and I would like to stress, it's a like for like repair, and there is no recipe, as I said earlier. So you have to experiment. You have to be patient. You have to experiment. And when I hear the stories from Lee about how they failed, the choice of wrong color of sand, and how it stained their stone after one rain or something, and I said, and then they just took the whole the thing down, the rebuild the entire wall. So I was quite pleased that it's so if you have to be patient. That's the bottom line basically, and there is no fixed recipe. So you experiment on a smaller scale, and when you are happy, then only use the otherwise if you fail on a larger scale, it's more time consuming, and cost will be higher as well. This is what they've been doing. Like what I'm doing on a wall, they were doing it and they call it lime biscuits. So they were using different compositions, and I was fortunate that I could use it on the wall, because my building was not as significant as York Minster. So that's Lee using different, and he was showing me that they have used different composition. All of them were recorded in these stickers. That how much was the lime, which lime they have used, what was the composition of sand, what other additives they added, and how much was the hair added, whether it is the horse hair or the sheep hair. So all that kind of stuff was very well recorded. And then when they see that, okay, this one works exactly like what I did in Malacca or in Singapore, and then you go for a larger section, whether it is full facade or full wall, or things like that. If you remember, I mentioned earlier that in the older times, and this is a close-up section of York Minster, and as you can see, with the lime, oops, sorry, with the lime, you can see these dots, black dots, and this is what the fuel used for burning limestone and getting the quick lime for building purposes. So earlier because they were building such a huge, so they were not bothered to have a very finer quick lime and segregate all these smaller particles of coal and everything. They're just building it, so and they need huge quantity, so just use it. So it will be part of the additive. Absolutely, it's a natural material. It's not going to harm, but they were not very bothered that it has to be super white. Lee was telling me about the York Minster, that how they were using slurry. There was some portion inside the tunnel, inside the turret, where they had a lot of air circulation because of the small windows, and that was actually eroding the fabric of the structure. So what they are doing is instead of talking about it and using some very fancy stuff, they just went there with lime slurry, and even for the floors, if you the steps, because they were inside that turret, and so they just repaired with lime, and they said they have to do it every 5 or 10 years depending how bad it is, and they don't mind doing it, and because they know it is the most compatible material, and they did it with the as you can see, not just with the steps, but also with the walls of the turret, and they just go and do a very thin layer of lime putty. They apply it there, very easy to apply, super less expensive, and it will prolong the life of the structure for many years. I'm going to quickly show you a short video. It's less than 2 minutes about the work which I did in lime plaster. And this video was prepared by the government agency here, the Urban Redevelopment Authority. It's for their 30 years of conservation. They were celebrating last year, end of last year. And this was, they're very proud of what we were doing. And we were very happy that they came to us and they produced the short film. And it's a fantastic film for us, for at least for me to show when I'm talking to a new person who is had no idea what lime is and why we have to use it. So I'll just keep quiet and play this. Padma, can you hear?
Yes, Nikhil, the audio is clear in this one.
Right, fine, good.
The materials we use to repair and conserve allows the movement of moisture, and that's where the white plaster comes. It's a porous material. It allows buildings to breathe. This is the most important place, I would say, in Paris, Singapore, where we can learn about the traditional building materials and also about the traditional building skills, the craft skills, and also learn about the spirit of the place and how people used to live here. See, for me, conservation of buildings is not just about buildings itself, it's about the people as well. What we are trying to do here is we can conserve the house for the future generations to use it in a way that is compatible with the spirit of the house.
So this is the last slide. I mean, I'm going to end in next 2 minutes. So I just want you all people who are here, you just to take one last thing from my 35 slides, 34 slides. Is for me, this is the most important, to understand the building's construction and the causes of its decay. Like I said, every building is unique, so the causes might be unique to the building itself, and to carry out honest repair. So I believe in William Morris's SPAP philosophy of honest repairs, and with like for like and compatible building materials, and using the traditional craftsmanship. It's very important that you use the right material and the right craftsmanship. And sometimes it's one or the other, and then the job is not good. And when you're using the right material and the right craftsmanship, especially with the lime, it will allow the buildings to breathe. And it is as important, because otherwise, if the buildings are not breathing, especially with our old buildings, is basically it is going to create a lot of decay. And if the buildings are not breathing, it's the same like the dead body. So dead body will not have sweat. So we want our buildings to show that damp patches and everything. That means the building is breathing. And as soon as you plaster it with cement, incompatible materials, or hard materials like the unbreathable paints, the synthetic paints and all, it's like you're actually suffocating the building with the plastic. And then in that case, like I said, the water cannot go out, evaporate, and it is going to cause problems to the structure, mainly to the either the soft materials, whether it is brick, stone, or timber, because most of these buildings are built with that, the older buildings, and they will actually decay, and it will, in the long run, it will be more problems. So honest repair, like for like repairs, compatible. So nothing, no need to fake anything. If it is a repair, it should be seen as a repair, and then people can appreciate the different layers of the history, different layers of the building, that different peoples have used it, they have repaired in a way, but it has to be compatible materials and craftsmanship, so that the old buildings repair. The last picture is from our Red Fort conservation, which was done a few years ago, and I'm quite pleased that it's the same way like Ho Chi Minh. They were cleaning the walls, and they found out the beautiful hand painted murals. It's the same way here. They found out and they preserved it in a very nicer way. They touched very little, minimum intervention, maximum retention, and then they repaired the things which needed to repair with proper compatible lime in a traditional way. Thank you very much.
Thank you. Thank you, Nikhil. That was a wonderful presentation. We have questions. People have been writing them down. So if with your permission, I'll start taking those.
Yes, please.
So the first question is, what factors affect the carbonization of lime?
It's the person who has asked is he or she here, because I need to know what factors, what do you mean by factors. Carbonation occurs is when I, like I said, when you are mixing, when you have prepared your lime mortar, and then you are applying. Once you have applied, carbonation is basically the process when the plaster is actually absorbing CO2 and becoming hard. When I say becoming hard, it doesn't become hard in a day or two. It takes time, and because it's a slow process of carbonation, is a slow process. Taking or absorbing carbon dioxide is basically carbonation. So you can the factor is basically your mix. You apply it, and as soon as you apply it, it starts absorbing CO2. So that's carbonation. And the factor is how fast it will or how slow it will. It also depends on certain climatic factors. I think it will be slightly slow when it is. Again, I have not done an experiment on this, at how carbonation works, but carbonation is basically absorbing CO2 from atmosphere. But I think the climatic factors will also affect how fast or slow it can happen.
Thank you. Basically, the question is, why do you think people have started using cement instead of lime? Is it because lime was expensive, or the cement making process is much easier? The making and application of cement is much easier. What is the main reason for this switch from cement to lime, from lime to cement? Sorry.
Okay. The main switch was industrial revolution. When there was mass housing, they wanted to build few hundred or maybe a full city or new town, things like that. So they wanted something which was like a quick fix, can, and then they wanted to go high rises. Lime, as I read few years ago, there was an experiment going on. It can easily go up till the sixth story. Again, you may or may not quote me on that, but but people say that, okay, only a small building can be, like a two-story building can be, like I've shown a lot of two-story buildings. They are mostly 2 or 3 story buildings. You cannot go high rise, but there was experiment going on in UK especially, that you can actually build a apartment blocks of 6 story high, easy with lime. In fact, people are also experiment that they can actually go mid rise. The main reason was industrial revolution. People thought that we need to go higher, faster, bigger, so we cannot use lime, and so that was the switch from lime to cement. But nowadays is the lobby, is the cement lobby. They are big businesses. They are multinationals. Whether it is Tarmac or JK White Cement or JK Cement and all, they are huge. They are multi-billionaires basically. So their lobby is very, very strong. And the way they market it, it's all about marketing. And so it took me 3 years here in Singapore to revive and to market lime as well. So now when I talk to people, and they are quite appreciative about it, because there's an understanding. So I think the main factor in the past, in early 20th century, was industrialization, which had this big jump from using lime to and how people market it. And again, the lobby. So use cement because it's faster, it's quicker. But trust me, if you use lime for on a larger scale, people ask me most of the time here, in the specification, the architects, is it expensive? How expensive it is to cement? That's the first question, and I can understand it, because if I'm an owner, I need to know how much it's going to cost. If it is 3 times more than the cement, then please use cement. Forget about it. But if you look at the long run, it is going to actually help your building, because you might save few hundred or a few $1,000s now, but in a long run, if you have to repair the entire wall, or your timber beams or your timber columns, things like that, then it will be much more expensive. So if it is a huge project, and I know in UK it is very, very cheap. I mean, it's cheaper to get lime than to get the cement basically, because it's readily available. But in this part of the world, I mean, I can talk about Southeast Asia. It is still slightly expensive to get lime because we are still manufacturing it in a small scale. Small scale is always expensive. But if I get a job tomorrow to say that I want to build a new town and get me lime for that, of course, a larger scale, mass produce, it will be much cheaper. So lobby, industrial revolution, and also in current is the marketing. But if it is a large scale project, you can actually negotiate with the supplier, and it will not be expensive.
Okay, thank you. The next question is regarding the percentage of impurities to be used in the plaster. Is it determined by the site conditions and availability of materials, or should some sort of material analysis be conducted on the existing lime mortar for us to create a similar composition for repair?
Okay, that's a good question. I forgot to mention that when I first started in 2016 to work with on Baba House, I actually got the analysis done. But what analysis tells us is sometimes it can tell you the composition. But what happens is in most cases, and I can give you the good example is Singapore. But if it tells me that it used lime from shells, but now I don't have that material here at all, because so what do I do? So okay, it's good to do the material analysis if you want to be super perfect, but you have to keep an open mind that in most of the cases the things have changed so drastically that the you might not find the same material, even though there was a query, or I mean, like I know from where they use the lime used to come here in Singapore for bigger buildings, the larger projects, was from Ipoh, which is not very far in Malaysia. But then if I and the sand, earlier the sand was we used to get it from Singapore River, but now we cannot do that. So how do I match the same sand which I've got in analysis? So analysis is one thing. I mean it can give you certain clues, but then you have to still keep an open mind to say that if you cannot find the exact same material for, like I said, for different reasons, the river is still here, but I cannot go and get the sand from that same river. So what do I do? So how do I create a compatible material? And that I can only do it with experimenting, either with small biscuits, or if I have the luxury, I can do it on actual wall and see how it reacts.
So sample preparation and testing is the best way to go about looking at.
Yes, but most of the time the owners are not very keen on that. The many issues like that. There's no time. The contractors have no knowledge, or you don't even have a lab. And I know INTACH has got a lime lab, but we don't have that luxury everywhere.
Thank you. The next question is, besides timber beams that we discussed, are there any other compatible materials that can be used just in case with lime while you're building?
Yes, no, there are, see, natural materials are the best. They talk to each other. So timber is natural, lime is natural, brick clay is natural. The clay bricks are natural. The same way that the tiles, our roof tiles or floor tiles, handmade ones in the past are natural. So the earlier builders were very green. So they were used, and they were very sustainable. They were not using steel or cement from different country or different part of the world and getting it to build. So whatever is in their backyard, they will probably use that and build it. So I would say, if you're talking about compatibility with the old materials, it's best to use natural materials. But again, we have to keep an open mind. If I now want to have a teak to repair my old shop house in Singapore, or in I don't get that teak. There is no teak. So what do I do? If the budget it doesn't allow me, can I use steel? Yes, I can, because I mean, if my fire regulation says I have to be fire compliant. So again, like I said, there is no fixed recipe. If you can use the natural compatible materials, they talk to each other. There is no doubt about it. But if you can't, because of many reasons, and I gave the example that there's availability is not there, the quality is not there, and you have to follow the new buildings have to follow when you are using the adaptive reuse, when you are changing the use, you have to follow the fire regulations and all. Then you have to use other materials like stainless steel and all, then you have to keep an open mind.
Thank you. Next question is, when we climb granite rocks, natural granite rocks, we do apply chalk to our hands for the grips. But most of the time we are told not to go beyond a certain radius because the chalk then starts damaging the granite structures. So the question is related. It's interesting question. It's asking whether chalk really bad for stones like granite? In that case, like, is lime not compatible with granite?
To be honest, this is the first time I'm hearing this. I won't fake that I know the answer. I have never used granite and chalk, because in this part of the world we are dealing mostly with timber, brick. Even in UK when I was working there, it was mostly timber, brick, and lime. So that's I would be very fascinated to know which, if the person can write here in the chat, where is this example of an incompatibility of
No, I think the question was they are told not to climb to a further distance with chalk, so that it will damage the granite. So it's not very clear whether it's the abrasive nature of the chalk it would damage, or maybe the grease from the hand. So it's just that question is parallel. So she's saying, is it because chalk is bad for granite? But if you think, Denicia, are you there?
Yes, I'm here.
If you could just
So this is in
elaborate on
Hampi.
this.
This is in Hampi. In Hampi, most of the structures are made with granite.
yeah,
So
yeah.
there are a lot of climbers who flock to climb those rocks over there. But we are not allowed to climb within the 5 kilometers radius inside that UNESCO heritage site.
Mhm.
So even besides the heritage site, there are good stones to climb on, but we are not allowed to climb there because the ASI department doesn't let us climb there. So we have to go really far away to climb. So the reason which they give us is that the chalk that we use is not healthy for the granite sculptures. So we are not allowed to climb there. So that is why I was very curious, is chalk really bad for the granite sculptures, or what is the reason?
Why do you use chalk? Is it for numbering or?
The
So
grip.
when we climb the rocks, we have to grip our hand on those very small
Right,
creases on the rock. So
right.
just because our fingers should not slip off the rock, we use the chalk in our hands. That is the only reason. But then we make sure we clean off the chalk from the stone, because we roam with a toothbrush so that we just rub off all the chalk from it. But still, we are not allowed to climb near the rocks which we really want to climb.
Interesting. I think they are afraid, if I think it's not to do with yeah, I think they are more afraid of the sculptures, of the you might damage, and of course both are kind of granular materials. So there might be, even if you use the brush or to clean, it might not be 100% clean, because if it has got pores and all, it will definitely go in. I don't know what's the quantity, because I've never done a rock climbing. I mean, you are great to climb, but then I have no idea what is the quantity of is it like a pinch of chalk, or is it a lot of chalk you are
No,
using?
we just dip our hand in the chalk bag only on the tips of the fingers. That's it. So that we just don't slip off. That is the only motive to use the chalk.
Interesting. I'm actually dealing with Kanderia Mahadev Temple, and I was in touch with Dr. PK Mishra just 3 days ago, and I will definitely ask him,
Please do. I
and
think
I'll come back to you. What is the actual reason why they don't allow? I will definitely come back to you through Padma, and I will ask him this question straight away after our talk. That why don't you allow chalk with granite? Because it's a very hard stone. So it's not that it's a very soft. It will crumble or something. So I have no idea. I mean, to be honest, I'm not going to give you something mumbo jumbo here, but I'm going to ask the right person, the authority, and come back to you.
Thank you. The next question is, while preparing lime putty traditionally, how do you measure impurities of quick lime?
Okay. when you say traditionally the people, I mean, is it the people when they were building or they were preparing lime putty? I'm sure they were not doing any test. But in my case, from where I buy my quick lime, it's a big company, and they don't actually supply it for lime. They make lime, but for because lime is used in different other factories in different industries as well. It is used for in the sugar industry, paint, cement, tarmac, water purification, many. It has n number of uses. So from where I buy my quick lime, I make sure that they give me a chemical specification of it, and so I know that the quick lime I'm using for making my lime putty has 95% of CaO, which is calcium oxide. Anything less than that, I'm not going to waste my time in making a lime putty, because once I make a lime putty, which takes few days, 3 or 4 days to mix and everything, and then I have to wait for 6 to 8 months, and in some cases maybe 1.5 year. In now when I'm using in Baba House in February to repair, I'm actually using lime putty which is 2 years old. So I don't want to waste all my this time when I don't know what is the chemical composition of my quick lime. So because you cannot go and query yourself limestone, you will probably have to buy it from someone. So when you are buying it from the supplier, make sure that you ask them, can you give me a chemical specification or configuration of how much percentage of CaO this contains?
Caleb, can you hear me? Are you there? Is it what you meant by impurities, or do you mean the things that you want to add to it?
Yes, ma'am. It is like impurities, because different brands are available in markets. So
Yes.
sometimes it's very difficult to choose right materials. That's why I'm like, yeah.
So 95% and above is what we have to look at.
Yes, Mr. Galeb,
Yeah.
look
Yes.
for 95% or above for CaO. If it is, and also look for what other impurities, because it will definitely contain impurities. So what other impurities it has. So if you see that there is a lot of magnesium oxide and there's other impurities are quite a lot, just reject it.
Okay.
Okay, thank you. The next question is, do you recommend the cement plastered surface to be redone in lime plaster by removing the cement plaster?
Yes,
In
if
few
it is originally done in you can always like that's exactly what I'm doing in Malacca, which I mentioned. The afternoon the project started. They started. I was actually trying to put the photographs here, but it was a WhatsApp picture, so the quality was not good. So I decided not to. But yeah, that's exactly what I did with my Baba house as well. I actually hacked the plaster which was there, which was causing problem, and then slowly repairing it the entire house with lime plaster, which I know is good quality and will prolong the life of the building.
But then the second part is also that there are few projects in which while doing this, the bricks crumbled terribly.
Yes, it happens. That's the reason you have to be very careful. You have to be careful, and no matter, it crumbles, but it doesn't come. If you're using the drill machine, it is quite bad. So what I tell the contractors, because the older the cement plaster repairs are usually quite thick in historic buildings, at least in this part of the world. So what I agree with them after negotiation is, yes, you can use the drill machine just to loosen the plaster, but after that you have to use the hand, the chisel and the hammer, and of course it's expensive, because it takes twice the time or 3 times the time, but then you make sure that your bricks doesn't get damaged, because the drill machine is going to definitely damage the bricks, and you'll get holes, or it even actually affects the foundation of the old buildings. So again, it's a matter of negotiation and compromise, how and of course how much money you have, but the proper way is you do it by hand completely. But if you cannot, just loosen the plaster using drill, and then remove the plaster. But there is no guarantee that the bricks will not be damaged, but it has to be minimum. But in the long run, if you are repairing it with lime pointing or lime plaster, you're actually enhancing the life of the building. So you have to see the pros and the cons.
Thank you. Next question is why putting lime for longer duration in wet conditions is considered good. What is the reason for this?
Because it sets slowly. Again, I give you a very quick example that when I was working with Baba House in Singapore, when we took the plaster out, and the next you have to dampen the wall because lime plaster doesn't like dry surfaces, so it has to have optimum wetness. And again, there is no fixed recipe for how much wet it has to be. So again, you have to try and test. So I dampen it one night before the plastering next morning. But then when we plastered everything and we went back home, the next day when we went there, the plaster was on the floor because it dried very fast. And because the wall was I thought that it is damp enough the entire night. We dampen it with sponge and everything. So I thought it is damp enough, but it was not, because it was dehydrated for hundreds of years. And then as soon as we applied the wet lime plaster, it just sucked all the water, and our actual lime was dry and it fell. So if you have the optimal temperature and moisture, it will help for the setting. And that's why we say. But even it is not advised in that it is snowfall and things. You don't do the plaster outside, because too much is also bad. So again, a balance. And so there is no fixed recipe. Too much water is also bad, too less is also bad. Like I gave you the example, it will just fall because water will be sucked by so it has to be optimum. And there is no fixed recipe for that. That's why I stress again and again that if you have the time, please do some small patches, and then you can. And then after that I realized, I said, that's wrong, because I need to actually wet it very too much. So I wet it, and then when the water was actually falling, and I know that it is super hydrated, then I applied the plaster, and it just was there forever.
Yeah, thank you. Next question is what kind of maintenance measures does one need to follow to prevent damage to lime structures? The maintenance of lime structures.
Okay, maintenance is the first thing, like I showed in the third or fourth slide, is the maintenance is like any other building. You have to have regular maintenance. You need to check whether the dampness is too much, or what are the causes of dampness. Actually, it's a dampness which causes damage to the plaster most of the time, and dampness from either from rain or from the under the floor. You have a drain, or now I'm having problems with Baba House, where we have a drain under the floor, which I didn't know because I was not there when it was built, and it is already covered. But then when we did the X-ray, we found out that it was leaking. It was broken and it was leaking. So a lot of water seepage from under the ground going onto the wall straight away. So we had huge damp patches, and it was also affecting the lime plaster as well. So all these regular maintenances to check, but to focus on whether the pointing is in good condition. Like I explained earlier, pointing is the one where the water will be released. So make sure that the pointing is in good condition. Otherwise, the water will start coming out from the bricks, and it will start damaging the bricks, or it will come out from somewhere else, some softer material. So the pointing is properly maintained. If not, then that's a cheap way of just repoint it with lime. Plaster is in good condition, and it's not just the plaster. You can actually have lime wash, and they have done it in Jaipur, the red. And actually, I was fortunate. I was there when they were doing it before the World Heritage nomination and everything. And they used rose petals and marigold and that sort of very natural pigments for lime wash. And in Jaipur, in Jodhpur, as we know, traditionally they use indigo. In Penang, they traditionally use pea flower, which is also blue in color. So they dry it, and then you add it into the lime wash, lime putty, and then you get a very beautiful blue color. I am using indigo, the natural pigment, traditional way. And also I'm going to experiment now, because I've got a wonderful proper lime wash from London last time when I visited, and I'm going to apply that, because it is another way of testing for me. So all these things, if you unlike the synthetic paint, which you have to do it every 2 years or 3 years, lime wash is very simple. You can prepare it. You don't need narrow lac or Dulux bucket or something, you can actually do it at home and apply it. So all these, so lime wash is in good condition because that is again a sacrificial layer. So if something happens, it will happen to it, and then you can apply it. So it's very cheap to reapply. So to check that the lime wash is in good condition, pointing for external pointing is in good condition, and yeah, of course that will help. That's a normal maintenance points basically.
The next question is, can we use lime surfacing on terraces in heritage buildings to prevent water ingress from ceilings? Or synthetic waterproofing is the only option?
Okay, it's I once thought about it, and people have done. You have to go and check. A lot of people have written about a thing called limecrete. So limecrete, like I showed in an example of York Minster, if you remember the steps in the turret, they used a slurry of lime, quite not very thick, not very thin. Otherwise, if it is too thick, it will crack. They have used it internally as a protective layer on top of stones. You can actually do it, but I cannot guarantee if what will be the condition, what will be the how long it can survive, because lime is a soft material. You have to mix it with something to make it slightly harder. And I'm guessing the people who have done proper research, PhDs and other experiments, a thing called limecrete. It's like concrete. Instead of concrete, it's limecrete. So there may be a possibility that you can apply actually limecrete, which is less damaging than the synthetic artificial waterproofing and all that kind of stuff, which is like a so try looking for if I'm doing it for and it is not very harsh situation like Rajasthan or in Delhi, or I would probably use it for a smaller section. But if it's a large part for terrace, you have to be careful, because and if it's a harsh conditions that the temperature variation is too high during summers and winters, then you have to be careful. Then it has to be something more than the lime slurry. It can be you can experiment with the limecrete. I've never done it, but I think limecrete should do the job.
Next question is, if you could name some methods, both destructive and non-destructive, for analyzing composition, strength, and age of lime in old buildings.
That's a technical question. I would go to my microscope people. They do actually you can collect without destructing too much. Of course, there will be a destruction, a small portion. You can actually cut it. It's absolutely no problem. And how deep you want to go? If you just want to analyze the certain layers, or if you really want, so it's not very destructive. It's not like you have to do a core drill or something to get an entire core, because like I said, lime is very, very soft. Even if it is 100+ year old building, I'm not asking you to go and damage some 100 years old building, but actually you can actually break the plaster very, very easy, and even with the bricks, the mortar between the bricks. So it's not very, very destructive. Again, I won't do it myself. I will go to a scientist, and I will ask them that I need a certain portion to be analyzed, and then they will ask me from where do you want to analyze, and then you can say, okay, I want to have some plinth area, maybe some bit the middle area, and maybe the top, and if you know that the building has gone through certain renovations for a few years, and then they go into under the microscope, and then they will tell you exactly what is. But I mean, to be honest, I'm not a scientific person. I'm a more of a hands-on person. But I'm sure the XRF and all these X-rays, what they do, the microscopic analysis will give you. But unlike the other cement or stone, where you have to drill a certain portion and take it out, to cut a lime plaster is much easier.
Thank you. The next question is, would you say that ensuring ventilation in lime brick built structures is crucial during monsoon seasons? And the other part is, what problems occur if lime putty is applied without aging it sufficiently?
Okay, I think I'll answer one by one. So ventilation, not just in monsoon, all the time is very, very important. And we are facing huge problems in Georgetown or in Malacca, or even mostly in Singapore as well, because all these historic buildings have changed hands, and now they are either offices or boutique hotels and things like that. So most of them are air conditioned. So windows are sealed. So they have a glass and it's sealed. So it's a building is have very little cross ventilation. Even the air wells, which were traditionally for cross ventilation and light and the what we call the courtyard, uh, in Indian houses, we have air wells here in shop houses. All these air wells are covered because it's running as a cafe and they want to maximize the sitting area. So the ventilation is almost like nil or very, very little. So what happens is that it's causing a lot of problems. And my advice to people is always like, for the Baba house and all, I tell them most of the time is make sure that when you are inside the building, when the people are using the building, that you open your doors and windows so that at least for 6 to 8 hours the building can breathe, and there's a cross ventilation. So that cross ventilation is the most important. I'll just give you an example. Very recently with the COVID, Baba House was closed for 3 months, and they got all the problems because of no ventilation. Because the 6 month for 3.5 months, the building was almost sealed. So the managers couldn't go in and then open the doors and the windows. So yes, so ventilation is quite crucial, not just in monsoon, but the rest of the days, the rest of the year as well. The second question was,
What problems occur if lime putty is applied without aging it sufficiently?
yeah, yeah. The only issue with aging is like I said, it's like a old wine. So it matures, and the taste for wine, the taste becomes nicer. If you're a wine enthusiast, you know that how the wine tastes. So the taste changes, and taste becomes even better, right? So same goes with lime. Of course, in lime the taste doesn't changes because you're not eating it. But in this way, when you're slaking, so there is enough time for even for the tiniest particle of your quick lime to slake properly. So there are no chunks. So it's like I said, it has to be like a buttermilk or chach, more than chach actually. I call it gooey cheese. So cheese or a set yogurt. So if you are having a cheese and you get a sort of a small impurity inside, you will not like it. So same thing if you're plastering, and if it is a properly slaked lime. So slaking is done, and there is no impurities because every particle has a chance to react with water and dissolve nicely. So the material you get for the plastering will be smooth, and that's the whole point for slating. The more it is slaked, the better quality. The better maturity, the better quality of slaked lime putty you will get.
Thank you. The next question is, any organic additives that you may use in preparation of lime mortar to increase its workability? What kind of?
Yes. I was reading about the Great Wall, and other. I was told the Threadford was built with it's lime plus pulses, dal, for mortar. Sometimes they even use in southern India for Madras chunam, they use egg white and jaggery, the brown sugar, for workability. In parts of China, they use even the blood of animals and rice for starch effect. So it prolongs the life of lime as well, the lime water. So yeah, different cultures. And I was interested that why were they were actually killing animals for their blood, but it was not like that. They were very smart. So when they were using the blood for the mortar preparation, they were actually they were using the meat for to eat as well. So that actually enhances their culinary skills as well. So that range, or that part of the region will have a better dish for that animal. So yeah, so from rice to animal blood to like I said, jaggery, egg white. There are many organic materials which can be and used. Brick dust, So all these additives can be added. But again, nowadays you have to be very careful what you're adding and why you are adding, because all these things are not readily available. A contractor might not even work. In my case, if I want to use let's say a pig's blood, and because it's non-halal, my Muslim contractor will not even touch it.
But your experience of any additives that you've added to increase the workability? Have you experimented with any?
No, because in the buildings which I have worked here are pretty simple. They're not very fancy buildings. I mean, although they are fancy, but they're not very high grade buildings. Not like Taj Mahal or Red Fort or even the Rajasthani Havelis, to be the intricate carvings and all that kind of stuff. They are pretty much like a middle class, upper middle class buildings. But I've tried using brick dust, but that's only for experiment, not for a large scale product.
Okay, thank you. The next question is, what would you consider lime? Is lime a soft material or is it as strong as cement? Relatively.
Okay, lime you cannot compare. It's not comparable as such. But if you start working with lime, it is you will find it very soft and so yes. Initial life of lime, if you're using for building purposes, it will be a soft material. But as the time goes, and we know, I have shown examples of huge cathedrals, not just in this part of the world, Pantheon, and all these the entire dome, which is I don't know how many meters, the diameter of that dome, they're all built with lime. So there is it is hard because it's standing for a few hundred years. So it's not like the one rainfall, one monsoon, and the whole building will collapse. So it's a different material. So you cannot compare it with cement, because cement is within few minutes it hardens, and then it doesn't change its chemistry. So it will be hard throughout its life. But when you are working with lime, it starts as a soft material, but then with the carbonation, it hardens and hardens and hardens, and until you demolish the building, it is still carbonating. Yeah. So and it is quite a it has the strength. That's why all these old buildings are still standing.
Thank you. The next question is, how old should be the slaked lime to be used in lime plaster? How many?
No fixed recipe. No fixed recipe. It depends on where you're applying. If it is like I said, buildings are unique, so that means your application will be unique as well. If I'm using it for like a masonry work, which is like the Great Wall of China or something like that, maybe my compound wall or garden wall or something like that, I will not probably use lime putty at all, because it's a fine wine. Why would I waste it for masonry work? But if it is like a plastering job, I will use lime putty. And my own idea of how old it should be is because in this part of the world, time is very constrained, right? So I can't tell my contractor or my client that, okay, wait for 2 years because I'm maturing the lime. They'll say, thank you very much. We will probably sell the building in 2 years. So I actually keep a ready-made supplies, and the minimum I would use is at least 3 months for internal plaster. But the more mature, it's better it is.
Thank you. The next question is, can China mosaic waterproofing be done with lime?
China mosaic waterproofing. I have no idea what China mosaic is all about.
Ayushi, you're there?
How actually it is different from a normal mosaic, is it?
That's the question. Can China mosaic waterproofing be done? The second part, of course, has been answered by you, which was repairing of cement can be removed. I think Ayushi is not there. So we'll move to the next question. Can we use food grade powdered calcium hydroxide for making lime plaster?
Oh dear, why would you do that? It's expensive. It's like washing your clothes with rose water or something. Unless you want to eat the lime plaster later, I wouldn't do that because it's a plaster. Why would I spend 10 times for a food grade when I can get it the normal quick lime? But to be honest, in short, I've never done it. But unless you want to eat the plaster later, I won't recommend. Use just whatever is available and cheaper, and it is good enough.
Okay, the next question is what would be the occasion for using hot lime? And have you used it for Baba House or
Yes.
elsewhere, and what is your experience with it?
Okay, the experience can differ. I know certain people in UK who have successfully used it, and they are. But like I said, hotline mix is morely for the masonry work. I tried using it for plastering in Baba House, mixing it and then plastering it, and I found out that it was not the best composition for my plastering work. But I know people in UK, they have used it successfully for masonry. Even the York Minster, they are using they are experimenting with hot lime mix, and they are very happy with it. Because like I said, the earlier builders in the past, they were very frugal, and they were very sustainable in a way. So if they have to do a masonry work like Great Wall or or any other defensive wall or fort, why would I use a very high quality lime putty for just for the masonry work? If I'm going to use it for internal render, basically, then the plastering, then I will use and like I said, I have used it, but I didn't find it suitable because I've got some cracks, and that might be because of many reasons. But I'm going to test it in with a friend of mine who I showed, Lee Godfrey. He's coming to Singapore. Hopefully, he can fly from UK, York, and then we are going to experiment our hotline mixes in Malacca, because there is other experimental center. So we are actually building a masonry wall with bricks, and also trying to do it on a larger scale. And I will get back to you if you can wait till February. It is doable, but mainly for masonry work. Plastering, I was not satisfied, so I will probably use lime putty.
Okay. Thank you. Now, Kirtida has been very nice. She's explaining now that China mosaic that we were talking about is a traditional method in India where we use broken pieces of glazed tiles. They're put together over a waterproofing screen. So this is the kind of thing, and can we use lime putty in repairing these kind of waterproofings?
You can. I know exactly what you mean. Gerard de Cunha of the famous Goan architect. He has done that beautiful broken tiles. The colorful ones. So thank you very much for explaining that. I didn't know that it was called China mosaic. But then yes, that's what I was telling earlier. Limecrete, which is quite successful in doing underground heating in UK, is using the same limecrete is used for the underground heating. And I think that can be also used. They have also used it for flooring as well, limecrete. So yes, you can have a limecrete, and then you can use you can actually use the broken tiles fixed on in that limecrete. So I think it should do the same job. It should do the same job as waterproofing, and it is more natural.
I think that's the last question. Okay, the next question is, Anupam is adding, but the difficulty with that is there's not much ingress of carbon dioxide to set it.
Yeah, limecrete actually uses NHL2. So you're not actually using lime putty for it. And carbon dioxide is free. It's everywhere. So unless you are using it in a basement or something, there might be an issue with that. But if you are using the like we were discussing earlier for the terraces, the waterproofing and everything, I think it should set. But if there is an issue of lime putty being too soft and it is not carbonating or properly, but then NHL2 will come to help, which is slightly harder. And if you look my slides again, it was actually used for slightly activities which are harder than the plaster. And NHL5 is for basically underwater things, the bridges and all aqueduct and things like that.
So basically what he's saying is unless you use hydraulic lime maybe, so better to use imminently hydraulic lime for China mosaic. Maybe that would work better for it than maybe the limecrete because of the carbonation. Would you?
Yes, but like I said, limecrete works perfectly fine I have not tried it here in this climatic condition in Southeast Asia, but in UK I know it is very successful. Now they are supplying for like most of the historic buildings for flooring, and because it is a natural material, and it the underground water can also evaporate very easily. So limecrete, and also for underwater heating, and sorry, underground heating, underfloor heating, it's quite successful. So I think if it is successful here, somebody has to do an experiment, whether China mosaic and limecrete, the composition of limecrete can work for waterproofing of either terraces, or if you are doing it for a decorative purposes in on the floor.
I think any more questions? I don't see any in the chat box. So I think that is all. I think time is also, we've crossed I think it's been almost, it's 7:30, exactly 2 hours. Oh God. So yeah, thank you so much, Nikhil, for your patience, and for the excellent presentation, and the question answer session was also very interactive and very useful. Thank you so much. Hopefully we will get to meet you again in future,
Yep.
maybe whenever we get a chance, maybe a new discussion, a new topic.
Yes, maybe after February, when I have tested my hot lime mixes and everything.
Yes,
Yep.
you're most welcome to share the experience with us. Thank you
Right.
so much. Thank you,
Thank you.
everyone. Thank you, everyone, for joining us.
Yes, thank you everyone for spending your 2 hours. It's 10 o'clock here in Singapore, so
Yeah,
so
so
I
yeah.
also yes. Thank you.
Yeah.
Bye
Bye. Bye.
bye.
Everyone. Thank you.